Assalamu alaikum wa rahmatullah wa barakatuh. Today in our video we will discuss the last section in chapter 1, simple discount at a discount rate. The calculation of present for discounted values over duration of less than 1 year is sometimes based on a simple discount rate. The annual simple discount rate D is the ratio of the discount D for the year to the amount of S on which the discount is given. In this situation, discount D is calculated on the final balance S and is paid at the beginning of the term T, whereas the most financial transaction interest I is calculated on the beginning of the balance B and is paid at the end of the term T. The simple discount D on an amount S for T years at the discount R D is calculated by means of formulas D equal S multiplied by D multiplied by T, and the discounted value B of S or the proceed B is given by B equal S minus D, where D is the interest or discounted interest. By substituting for D equal SDT, we obtain B in the form of SDT, B equal S minus SDT. Taking S as a common factor, you will have B equal S multiplied by 1 minus dt. The factor 1 minus dt in the formula 5 is called discount factor at a simple discount rate D, discounted factor. Simple discount is not very common. However, it should not be ignored. Some financial institutions offer what are referred to as discounted loans. For these type of loans, the interest charge is based on the final amount S rather than on the present value, which is B. The lender calculates the interest, which is called discount D, using formula 4, which is D equal SDT, and deducts this amount from S. The difference B is the amount the borrower actually receives. B is the amount actually borrower receive, even though the actual loan amount is considered to be S. The borrower pays back S on the due date. For the reason, the interest charge on the discounted loans is sometimes referred to as interest in advance, as the interest is paid up front at the time of the loan instead of the more common practice of paying interest on the final due date. In theory, we can also accumulate a sum of money using simple discount. We also can accumulate a sum of money using simple discount throughout it. It is not commonly done in practice. From Formula 5, we can press S in terms of B, D, and T as this formula. Instead, B equal S multiplied by 1 minus dt. We want S, then divide by 1 minus dt. The factor 1 minus dt to the power negative 1 in Formula 6 is called accumulation factor at a simple discount rate of D. Notice the difference. 1 minus dt is called discount factor at a simple discount rate D. Here, accumulation factor at a simple discount rate D. Formula 6 can be used to calculate maturity value of the loan for a specified proceeds. Here, example number 1. Example number 1, page 25. A person takes out a discounted loan with a face value of 500 for 6 months from a lender who charged 9.5% simple discount rate. Here D. Here is what is the discount and how much money does the borrower receive. He wants D, and he wants also B. D SDT, which is this, and B will be S minus D. You will have this, or you could calculate B proceed by Formula 5 by probability S multiplied by 1 minus dt and calculate it. But in order to find D, you must multiply S dt. What is happening in this situation is that the borrower receives a loan of 500, but he must pay 23.75 in interest. Charges today. He ends up with a net of 476.25 in his bucket. 6 months later, he repays the original loan amount $500, but doesn't pay any interest at that time. He has already paid the interest up for solution number B. Here, what size loan should the borrower ask for if he wants to receive $500? Receive means S. Calculate S. Here, if B $500 and D is 9.5%, T is 6 months, which is 6 over 12 half, then you will have 524.93. The borrower should ask for a loan of 524.93 to receive proceed of 500. This is B, this is S. Question number or solved example number 2. Calculate the discounted value of $1,000 due in 1 year at a simple interest rate 7%, at a simple discount rate 7%. Here S 1,000, discounted value of, which means B. Find B. This is S equal 1,000. Here, in order to calculate S, B equal S over 1 plus RT. Here R 0.07, 7 over 100, and T is 1 year, 1. You will have this. But if we have discounted simple discount rate, D equals 7, then B equal S multiplied by 1 minus dt, then you will have 930.0. Notice here, S in case of simple interest rate is greater than S when we have discounted, simple discounted rate. Notice this, the difference of it, that they are greater. Notice the difference of 4.58. Here, subtract. Difference between the discounted value at a simple interest rate and the discounted value of simple discounted rate. We can conclude that a given simple discount rate results in a larger money returned to a lender than the same simple interest rate. In A, the borrower is taking out a loan of 934.58 at the end of 1 year. He or she pays back the original principal of 934.58 plus interest of 65.42 for total of 1,000. The borrower is taking out a loan of for $1,000. He or she pays $70 in interest up front, receives 930, and repays the original principal $1,000 at the end of 1 year. Here, calculating the true rate of simple interest for the discounted loan. For this example, be sure that they have the same interest rate. This is why we make comparison. In a simple interest loan, the borrower receives the full face value of the loan. For a discounted loan that uses simple discount, the borrower receives the proceeds, which is the face value less the discount. Value less the discount because the proceeds are less than the face value. Yes. B always less than S. The stated discount rate is not the true or actual interest rate on the loan. As you will see, the actual simple interest rate on the discounted loan is higher than the stated simple discount rate. Example solved, example number 3, page 26. $1,200 loan. Loan means قرض. has a maturity value of 1,260. This is S. This is B. Due at the end of 9 month time, 9 months, calculate annual simple discount rate, assuming that is a discounted loan, find D. The annual simple interest rate, assuming that the regular simple interest loan, find R. Here, S 1,260, D equals 60, since S minus B equal D. And T 9/12, and calculate small d equal D capital over ST. You will have 6.35%, but you will have the answer 0.0635, but multiply it by 100 in order to have 6.35%. We have B equal 1,200, I equal 60, T equal 9/12. Then calculate R equal, this is for memorizing, and this is, you will have here how much? 0.0667 multiplied by 100, you will have 6.67%. Here in example 3, we see that simple discount rate D is not the same as simple interest rate 6.35. Instead of D equal 6.35% is the same as or is equivalent to the simple interest rate R equals 6.67%. In other words, if you take out a discounted loan at D equals 6.35% for 9 months, you are already taking out a loan at a true rate of simple interest 6.67. But how can you determine the true rate of simple interest on the discounted loan? You need to calculate the equivalent rate of simple interest. In general, we can calculate equivalent rate of interest or discount by using the following definition. Two rates are equivalent. This is very important idea. Equivalent if they lead to the same accumulated value of a fixed sum of money over the same period of time. The above definition can be used to determine simple or compound equivalent rates of interest or discount. Note that the simple rate of interest and the simple rate of discount in example number 3 are equivalent rates, as both of them accumulate $1,200 to $1,260 over 9 months. Here we will have example number 4, page 27. We take out a discounted loan at a simple discount rate of 8.4%. What is the actual rate of simple interest you are being charged if the loan is paid back in 3 months, in 205 days, and 1 year? Assume the The amount received today, $1. You need to compare the accumulated value of $1 for 3 a month under simple interest and simple discount. You have here B multiplied by 1 plus RT equal B multiplied by 1 minus dt to the power negative 1. You can cancel B. You will have here 1 plus RT equal 1 minus dt to the power negative 1, where this is a simple discount, simple interest rate, and this is simple discounted rate. Here you will substitute. I want to calculate the rate of simple interest. Instead of during 3 months, 1 plus R multiplied by 3 over 12 equal 1 minus. Here you will have 8.4 divided by 100 multiplied by 3 over 12 to the power negative 1. And after simplification, you will have I equal 8.58. The value will be 0.0858 multiplied by 100 and put the percent. When T is 205 days, here the same, but divide 205 over 365. And after simplification, you will have R equal, compare the accumulated value of $1 for 1 year. Instead of T, put 1, and you will have the value of R. Observation. Note that for simple interest rates of interest and discounted, the equivalent rate are dependent on the period of time, and that for equivalent rate are greater than D. Yes, it is greater always. R greater than D always. You will see that D is 8.4. D 8.4%. This is 9.17. D 8.4 here, R 8.82, here R 8.58, and D is 8.4. Then always R greater than D. Application 4 of simple discount promissory notes. Promissory notes are occasionally sold based on a simple discount from the maturity value, and as illustrated in following examples. Example number 5, page 28. On August 10, Smith borrows $4,000 from John and gives John's promissory note at a simple interest rate of 5% with maturity value of maturity date of February 4 in the following year. Yani means from August 10 to February 4. Mr. Brown buys the note from John on November 3. In November 3, here, based on, then he buys the loan from John buys the loan, or Mr. Brown buys the loan from Mr. John when before the accumulated date, before the maturity date, which is now discounted date, November 3, based on a simple discount rate, which is D 6%. Determine Brown's purchase price and determine what rate of simple interest Brown are needed, and also he needs to calculate B. Solution: we arrange the dated time values on a timeline. Timeline begins from 10 August till February 4, which is maturity date, but there is a date for discounted, which is November 3, and there also discounted the rate, which is 6%. Here, you know that we have August, September, October, November, which is here, December, and January. February. You notice here, number of days, 1 equal August 31 minus 10 plus 30 plus 31 plus 30 31 plus 31 plus 4. You will have how much? 178 days. But number of days discounted equal, here you will have 428. Let's see. Here you will have December, January, 31 plus 31. Also, you will have 4 plus 30 minus 3, which is how much? 93 days. Here 93 days. Then return back to calculate. We want proceed and we want R. Maturity value of the note, S equal. This is the proceed, which is here proceed. 4,000 multiplied by 1 plus 0.05, which is simple interest rate, multiplied by 178 over 365. It will be 4,997.53. Since Mr. Brown is buying the note using a simple discount rate, the proceeds are determined using Formula 5. Then the proceed will be B equal S multiplied by 1 minus dt. Then substitute by this S 1 minus 0.06 multiplied by 93 over which is discounted date 365, it will be $434.89. The amount paid by Brown to John is this amount, $4,034.89. To determine the rate of return that Brown earns, there are two methods that can be used. Brown earn I, calculate I means S minus B. S minus B, S which is maturity value, minus proceed, you will have 62.64 of dollar over 93 days, and R will be I over BT. I, which is 62.64 over 4,034.89 multiplied by 93 over 365. Then, which is 6.09%. Alternatively, you can calculate for $1 for accumulate $1 for 93 days under 9D equals 6%, and R can be calculated by this formula. This, it will be 1 minus dt to the power negative 1 equal 1 plus RT. And find R. Then here multiply by 100, you will have the answer by putting percent, since it is interest rate. Thank you. Now homework, page 29, number from 1 up to 11, and I will solve with you some questions, but in next video. See you next video. Thank you for your listening.